Section 1. Earth's place in space. Communicating with satellites. In 2010, a major earthquake hit Haiti. It was so powerful that it affected about 3 million people. It damaged or destroyed thousands of buildings. Many people from around the world came to Haiti to help the country recover from the earthquake. One challenge after a major disaster is that much of the infrastructure is often damaged. Infrastructure refers to the physical structures and facilities that help a society or organization function. For example, the earthquake in Haiti destroyed many cellular towers. This made it almost impossible to use cell phones in the days right after the earthquake. Satellite phones. Many international groups use satellite phones to communicate when they couldn't use cell phones. Satellite phones don't rely on cell towers or other infrastructure on land. Instead, they use satellites that are orbiting Earth. To orbit means to move around another object in a complete path, such as a circle or an oval. The satellite phone uses those satellites in space to send information rather than cellular towers. Using satellites helps people who wanted to coordinate the delivery of important goods, including blankets and plastic sheeting that people could use for shelter. Orbiting in space. There are thousands of satellites currently orbiting Earth. A satellite is a body that orbits another body in space. The moon is a natural satellite that orbits Earth. The satellites used by satellite phones are artificial because they are made by humans. Both natural and artificial satellites orbit Earth because of gravity and inertia. Remember that gravity is the force of attraction between all matter, and that Earth is so massive that its gravitational field extends beyond the atmosphere, pulling on all objects within it. Earth's gravity. The force of Earth's gravity doesn't pull the moon or the other satellites down to Earth's surface. This is because all objects in orbit are also moving sideways. For example, the moon moves at a speed of 3,683 kilometers per hour. If Earth's gravitational field didn't exist, all satellites would travel in a straight line because of inertia. Inertia is the tendency of an object at rest to remain at rest, and an object in motion to remain in motion unless acted on by an outside force. If a ball is at rest on the ground, it will not suddenly start moving on its own. It needs an outside force, such as you kicking it, to cause it to move. Similarly, once the ball starts moving, it will continue moving forever if no other forces act on it. However, here on Earth, both friction and air resistance eventually cause the ball to slow down by transferring energy out of it. In space, Earth's gravity provides the outside force that changes the motion of its satellites. Without it, the moon and other satellites would speed through empty space in a straight line. However, Earth's gravitational field is so strong that its attractive force pulls on the satellites as they move. For an object to remain in orbit, its speed must be balanced by the pull of gravity. If its speed is too slow, it will fall back to Earth. If it is too fast, it will fly off in a straight line in space. This is similar to the motion of a ball on a string. If you swing the string around, the ball is constantly being pulled toward your hand. This is similar to how Earth's gravity pulls the moon and other satellites toward it. But the ball's sideways motion around the string keeps it moving, so it doesn't fall to the center. Without that pull to the center, for example, if you let go of the string, the ball would go flying off into a straight line away from you. Satellites orbit at different speeds and different distances from Earth. Some satellites are geostationary. These satellites travel from west to east over the equator. They are called geostationary because they move in the same direction and at the same speed as Earth. As a result, it appears from Earth as though they don't move because they are always above the same spot on Earth. Moon, Earth, Sun system. Each of the satellites orbiting Earth form a system made up of them and Earth. For example, Earth and the Moon form an Earth-Moon system. They form a system because they are connected, interacting parts that make up a more complex whole. At the same time as the satellites orbit Earth, Earth itself is in motion, orbiting the Sun. The sun is a star at the center of a solar system. A solar system is a collection of planets and other objects that orbit a sun. A planet is a body that orbits the sun, is massive enough for its own gravity to make it round, and has cleared out smaller objects around its orbit. There are currently 8 known planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Earth and all of the other planets are themselves satellites because they orbit the sun. The sun. All of the planets orbit the sun for the same reason that satellites orbit Earth: gravity and inertia. The sun is so much more massive than Earth that its gravitational field pulls Earth and the other planets into orbit around it. The sun plays another important role on Earth. It provides energy to the planet in the forms of light and heat. It does this through exothermic reactions that take place deep within the sun's interior. Remember that exothermic reactions are chemical reactions in which energy is released into the environment. The light and heat produced by the sun are evidence of these exothermic reactions. That energy is transferred to Earth through radiation. Radiation is heat transfer that occurs without contact between the heat source and the object heated. We'll explore radiation more in the next lesson. As the sun shines, it lights up Earth. However, Earth is also rotating or spinning once every 23 hours and 56 minutes. As it rotates, the sun lights up half of the planet at a time. This is day and night on Earth. Throughout the year, different parts of the planet experience variations in the number of hours of daylight compared to night by the length of one complete day, but the length of one complete day is always 23 hours and 56 minutes. The sun also lights up the moon. The moon doesn't emit its own light. Instead, we see the moon because the sun shines on it, lighting it up for us. This is possible because the moon reflects the sunlight. The light bounces off of the moon and then travels to Earth. The lit part of the moon that we see from Earth depends on the moon's position in space relative to Earth and the sun. The moon's position in the solar system. Let's explore the moon's position in the solar system a little more. You may have heard of the dark side of the moon. This phrase came about because here on Earth, the same side of the moon is always facing Earth. However, it isn't true that the side of the moon facing away from Earth is always dark. Just like on Earth, half of the moon gets light and then dark as the moon rotates. If the moon didn't rotate at all, we would see both sides of the moon as it orbited Earth. However, the same side of the moon always faces Earth because it takes the moon about the same amount of time to complete one rotation as it does to complete one orbit around Earth. The moon completes one rotation and one orbit around Earth in approximately 29 days. Because both of these motions take the same amount of time, the same side of the moon always faces Earth. The moon cycles. As the moon travels around Earth over the course of a month, it appears to change from a full white disk in the sky to a small silver and then back to a full white disk, a small sliver. These changes are called phases. There are 8 phases in the moon cycle, which describes the changing appearance of the moon as seen from Earth as it orbits Earth. The moon cycle occurs because of how the sun's light reflects off of the moon and back to Earth. It changes over the course of a month because the moon changes its location in space as it orbits Earth. For example, new moon is the first phase of the moon cycle. It occurs when the moon is positioned between Earth and the sun. Because the moon is in between the sun and Earth, the entire half of the moon lit by the sun is facing away from Earth, so the moon is not visible from Earth. As the moon continues its orbit, the amount of sunlight reflected off of the moon and back to Earth changes. The part of the moon lit by the sun increases, but it is still less than half. This is the waxing crescent phase of the moon cycle. As the moon continues its orbit, it reaches a point where it is at 90-degree angle relative to Earth and the sun. This is the first quarter of the moon cycle. From the northern hemisphere, the left half of the moon appears unlit and the right half of the moon appears lit. After the first quarter, the sunlit part of the moon continues to increase. This is called the waxing gibbous phase of the moon cycle. When the moon reaches the opposite side of Earth, we see a full moon from Earth, where it appears round and bright. The moon, Earth, and the sun are lined up similarly to new moon, but the moon is on the opposite side of Earth. As a result, the entire half of the moon that receives sunlight is facing Earth. After full moon, the sunlit part of the moon begins to decrease. The waning gibbous phase occurs when more than half of the moon is lit by the sun, but the lit part is decreasing. As the moon continues its orbit, it again reaches a point where it is at a 90-degree angle relative to Earth and the sun. This is the third quarter. From the northern hemisphere, the left half of the moon appears lit and the right half of the moon appears unlit. Following the third quarter is the waning crescent, which wanes until the light is completely gone, beginning the cycle again with new moon. Depending on the moon's exact position in its orbit, it can sometimes block the sun's light from reaching Earth. This results in a solar eclipse. An eclipse occurs when one object in the solar system moves into the shadow of another object. In a solar eclipse, the moon moves between the sun and Earth. If the moon's shadow falls on Earth during new moon, it appears that the sun has become completely dark. Solar eclipses do not happen every month. This is because the moon's orbit around Earth is tilted 5 degrees. As a result, the alignment of Earth, the moon, and sun only occur about once every 6 months. A partial solar eclipse happens when the sun, moon, and Earth are not exactly lined up. The sun appears to have a dark shadow on only a small part of its surface. For a total eclipse to take place, the sun, moon, and Earth must be in a direct line. During full moon, a lunar eclipse can sometimes occur. In contrast to solar eclipses, lunar eclipses occur when Earth moves between the sun and the moon. During a lunar eclipse, Earth blocks the sun's light that normally reflects off of the moon. Lunar eclipses can only occur during the full moon when the moon passes through Earth's shadow. The moon does not completely disappear during a lunar eclipse. Instead, it appears reddish. This is because light from the sun must first pass through a long and dense layer of the Earth's atmosphere before it reaches the moon. Just like the solar eclipse, lunar eclipses do not occur every full moon.